Hello, my name is Felipe Herrera, and this is my final lab, Physics 2211, Lab 5. So, for this lab, I was a little spent on time. I decided to use one of the videos that they provided, so I did the slinky video. So, observe the motion of a slinky falling from equilibrium and create a model in GlowScript. So, here's some formulas that I needed to use. VF equals VI plus Fnet. Plus Fnet, and which is equal to dp dt. So RF equals Ri plus V average times delta T. Force gravity equals mass times gravity, and force net equals dp dt. So here's my little tracker video. It's quick because the video is quick, but basically I just went frame by frame. And I put the point at the bottom of the slinky because that's what we're monitoring. So here's the tracker graph. Basically, the X, don't pay attention to that. That's just like the, if I didn't click perfectly on the line, but it's the Y. So the big thing is that you'll notice that it starts in the exact same place because it doesn't actually fall. Like the bottom of the slinky didn't actually fall until the top of the slinky met it. So this is when the top of the slinky met it, and then this is when it's on the ground, and then most of my video is just after it fell, so that's what all that is. So here's GlowScript initial conditions. I just basically established, like what the graph is going to look like and stuff, and then I set the mass of the slinky to be 0.3 kilograms, the initial position vector to be negative 1.3, and then basically just like a similar rounded number to the previous from tracker. So then I have my initial vector, the velocity vector 0, 0, 0, and some constants. So here are my while loops. Just basically formulas so that it's gonna kind of cancel out force gravity and force tension, so that's what is going to make the graph be flat, and then after the top of the slinky meets it, it's just going to be their mass falling. So here's the graph. I don't really know what that green is, but we're going to ignore it. But here's the blue. So here you can see the same thing pretty much. It stays still and then it falls once the top meets it. So results, according to the graph, the bottom of the spring does indeed stay still, just like in the video. Is due to the gravitational and tension forces being equal in magnitude, which means that the bottom of the slinky will not fall until the top meets. So here's some possible errors. So obviously tracker error. I mean, you saw it a little bit, with the X, and then that's just me clicking frame by frame. So of course there's going to be some error. And then computational forces equations error. I don't think I messed up any of the equations, but there could be a lack of some. So thank you for watching my final lab.